Welcome everybody to Turbocharge, your Exchange on-premises and hybrid environment. Notes from the field. My name's Steve Goodman. I'm an Office 365 and Microsoft Exchange MVP. I've been doing Exchange pretty much my entire career. I don't think I look that old, but about 20 years, and Office 365 from the beginning. And today I wanted to, first of all, ask some of these questions. So, Greg Taylor wanted me to come up with a better name for the session, and I thought turbocharging sounded really good. I've got to say, there's not going to be a picture of a 286 with a button on the front through this deck, though, just to warn you. But I want to tell you why you might want to turbocharge Exchange. So this is going to cover a few of the key core concepts if you're looking to deploy Exchange today. And Exchange 2019 isn't out yet. 2016 is, but a lot of the advice applies to both. Not much has changed in terms of the things you need to do to get it right. So we're going to tell you what the best way is to deploy it. And just a quick show of hands, how many people virtualize Exchange? Oh God. I've got a customer I'm working with at the moment doing the same thing, and I'm going to help do it. So I'm not going to tell you, I am going to tell you not to do it, just like I told them. But if you've got to do it, you've got to do it. So where do we put that turbo button? There's no physical hardware to stick it on. And some tips to try and make sure that you do it the first time. So in previous Ignites and TechIts, there's always been sessions on the whole of doing it right the first time. So what we're trying to do is condense into 45 minutes all of that advice that you might not have seen for the first time, maybe if you're deploying it today and you've never done Exchange before, and try and condense that into one session that gives you things I've learned, because I mess things up sometimes. And the advice from Microsoft as well. So it's a mix of the two. And there's a hybrid bit in this too. So this isn't going to be the entire hybrid for the long-term session or hybrid tips and tricks, but if you want to accelerate that migration to the cloud, what do you do to make that migration faster? Should you brought Exchange servers in? No, David, don't. Or should you do some other things? And we'll talk through that. So what's the best way to deploy Exchange servers? So we're going to start with some of the key design principles for Exchange. And this is the advice that Microsoft have been given for years, and it's completely correct. So first of all, we want to design a solution that is going to be available in the event of a failure. People say that no one likes email anymore, but take it away from them and you know you have a problem. It's one of, if not for the phone system, it's one of the most critical systems in any business. And if you're still going to do it on premises, you need to try and make sure that it's completely redundant. And a great way of trying to make sure that it's available is make sure that you reduce anything that's complicated within it. Simplify it as much as you can. And of course, make sure that if you're not just going to deploy it into one rack or on one server. It's an important system. And things have changed. Email isn't just the thing you use to send and receive. It's part of a wider productivity suite. The majority of the customers I'm dealing with, even if they're staying on premises, they are looking to do other things as well. They might be looking to use Microsoft Teams as part of their voice replacement system, and they might want that integration with on-premises Exchange. They expect a lot more. They might expect modern attachments. They might expect all of the functionality that they get if they move to Office 365. And that's a common thing I hear. We're not going to the cloud completely, but we want the same kind of experience for on-premises, because in the cloud, all of these things are built pre-integrated. You should probably be planning on-premises to integrate those as well as you can. Bigger mailboxes. If any of you are running Enterprise Vault or one of those other archiving solutions, you may have good reasons to do so. But the Microsoft recommendation, and what I see with success with customers, is using large mailboxes. So they have all of that data in one place, not necessarily mailbox and archive mailbox. They're just bigger mailboxes like you get in Office 365. And that hybrid integration, so being able to use some of the things that you might get as part of your Office 365 subscription if you've got one, or EMS, to allow better remote access in a modern way. And we want to try and make it value for money as well, because you can design a solution for an enterprise that costs £1 million, or you can design one that costs £10 million. So if you're using commodity hardware, and I don't know whether this is a term that I've coined, but instead of RAID and having availability at the disk level, have lots of servers. If you lose one, then it doesn't matter. If you lose a server, the solution should carry on running. Leverage the native capabilities within the product as well, if you can. And in the real world, I don't see Exchange native protection used as much as I'm sure Microsoft would like. But we can still work with other technologies as well. But ideally, if you start with those things in mind, that you are going to see whether you can use native protection, lag copies, JBOD, just a bunch of disks, then you're going to be on the right track, even if you can't achieve all of it. And storage. Using cheap storage is fundamental to Exchange. If you heard about Exchange 2019's flash-based tiering, then that's still quite a simple model. Cheap disks, but then 3:1 type ratio with flash storage as well to further improve performance in 2019. But it is about making this as cheap to build and run as possible, but like Microsoft are doing when they're building their own services. So our starting place is preferred architecture. And this is the quick preferred architecture primer of a couple of slides. And the best way to describe preferred architecture is it's a predictable way to deploy Exchange. So rather than build something custom, maybe go for the turbocharging thing here, building your own kit car, that might be great, but it might not be reliable. And what garage will you take it to if things don't work? You're going to have to fix it yourself. Somewhere outside of that, there's going to be an Alfa Romeo, not so reliable, nice car, great. But preferred architecture sitting there with Ford, General Motors, I was going to say Fiat, mate. It sits there with mass manufactured, reliable cars that you can trust. You're deploying it in a way that reduces the risk because you're learning from how Microsoft have done it in the cloud. You're learning from their principles for doing it in a way where before you even start drawing this out on paper, you have an idea of what it's going to look like. You don't have to think about so many of the variables. You know that it will be commodity hardware. You know that it will be done in a certain way. And if you can't use it, just take as much of it as you can. Maybe you still need to do backups. Then still do them. Maybe you do have to virtualize. There's parts of that you can take as well. And a custom design can be supported. And sometimes people say preferred architecture is the only way of doing it. Custom designs are fine, but it increases the risk associated, and it makes things far, far more complex as well as expensive. So a quick primer on what preferred architecture is. So rather than use the slides that Ross has been showing over the last few years in a 75-minute session, I'm going to, hopefully not too badly, attempt to give you a quick primer of what that is in just 2 slides. So it's made of 4 bits. The first of those is the namespace design. So a single unbound namespace per data center pair. I'll tell you what unbound means in a little while, but basically a name that's not attached to one particular data center. We use layer 7 load balancing with no affinity. That's a load balancer that doesn't just pass the traffic through, it understands the URLs, the HTTP URLs that people are attempting to access and can do clever things with them. But we don't have any affinity. We don't make sure that a client stays stuck to the same server each time. And we use equal distribution of traffic across those data centers. So if a client first accesses their mailbox or logs into OWA into data center 1, the next request to create a new email might hit the second data center. That's the plan. And for multiple data center pairs, either a single namespace worldwide, mail.contoso.com, or regional namespaces, North America, na.contoso.com, EMEA.contoso.com. Data center design, then we have at least 2 well-connected data centers. So we're splitting across 2 data centers so we can have a failure. They have good connectivity between the 2 to start with. And they must be in their own Active Directory site. That's essential to make sure that we've got site resilience for transport, so mail can flow properly between our systems. And from there, if you can, it's recommended to have a 3rd well-connected site for the file share witness. The file share witness is our casting vote for whether the cluster should stay online in one data center or another. Second part of that, the last 2 pieces, is server design. And this is where I've heard people say, I'm going to do preferred architecture, but in a virtual environment. One of the requirements for preferred architecture is that all servers are physical, commodity hardware, so 2-socket servers like DL360 type servers with a storage controller that has battery-backed cache so that you get good performance when you're writing to disk. It's critical. And large form factor disks, slower large form factor disks like midline SAS or SATA 7200 RPM. That's the model for the kind of storage you have. And sometimes compute teams in enterprises say, well, we always put the OS on one disk, the applications like Exchange on another. For preferred architecture, we have a single RAID 1, which might be our 10 terabyte RAID 1 disk, with the OS and Exchange with its transport database queue, with all of the CAS log files, as if that's a role, the IIS log files, all of these pieces, all the logging, database, installation files, they all live on a single RAID 1 disk alongside the OS. And the remainder are just a bunch of disks. Disks without RAID. They are disks that if you pull it, you lose the data. But that's all right, we've got it somewhere else. Instead of having 2 pairs of servers with RAID 1 mirroring, we've got 4. That's part of the model. And we have at least 1 that acts as the auto-reseed disk. So just like a RAID type infrastructure, we've got a disk that's sitting there waiting for the disk failure so that it can begin reseeding the data if there's a failure. And the DAG design, the database availability group, the key component of Exchange that deals with replicating mailbox data between different servers. We run this in an active-active model, which means we have active databases with active mailboxes in both data centers, ideally at all times, unless there's a failure. And 4 database copies with 2 per site. And rather than scale up these servers and buy 4-socket servers or buy much bigger servers, trays of disks underneath, then what we should do is we should add more servers to the DAG, then add multiple DAGs if we need to as well. Scale out rather than up. And key piece of this, again, and this is where people say, well, we might almost get to preferred architecture, because here, using native protection, using lagged copies, a lag copy is where the database, or one of the database copies, isn't played up to date. So if there's a massive problem in the morning, a database is completely corrupted, then because we've not got separate backups, then we can call Microsoft support and roll forward and fix that last copy of the database. And to make sure that if a user deletes something really important, they need you to recover it for them, then we either have single item recovery or in place hold to make sure that people can't delete anything until the business thinks that that's okay. And a single network interface card in these servers to be used for both client and data replication. So what if you can't do all of that? What if you need to back up? Then you can still do this. So I've seen customers, I talk to my fellow MVPs as well, who you may have seen at other conferences talk about similar tech. You know, what should you do in these scenarios where somebody wants to back up but they're doing preferred architecture? It's fully supported to do preferred architecture. From Microsoft's perspective, it might not be the best way, but to, instead of using circular logging, where after the rights to a database are committed to the database file, they're thrown away, we don't use circular logging. We back up those logs in the database in the more traditional sense, but using the rest of preferred architecture. Because sometimes businesses do have, perfectly valid point from one of my customers was they wanted to go completely preferred architecture, but one of their teams said, we've got a big fear that somebody could, or the servers could get infected with one of these viruses that encrypts everything on the disk. If that affects all of our servers, then we will have lost all the data. And for that reason, we won't support you not having a backup solution. So they have one, and it works well for them. But we then needed to, this is where it adds complexity, we had to make sure that we had enough room for the longest period of time that we might go without backups as well. We're sizing for that anyway in terms of server failures, but we had to then do more work to make sure we don't get caught out by that risk in the future. If you can't use JBOD, then try and take as much of the rest of that as you can. If you don't feel your organization is ready yet to manage disk failures, with 2016 and above, you're in a much better place to be able to do that because you've got things like auto reseed. You don't have to work this out for yourself. But if you're certain you can't do it, then you can still use commodity hardware. You'll just need more disks, potentially. If you need to virtualize, I'll talk through some of the bits a bit later on that you can take away and actually use. Maybe not the physical hardware pieces, but just use as much. And if you haven't got a well-connected third site, then you can still use that model where you have a primary file share witness in one data center, and then an alternate in a second one in case of another failure or having to move those things around. It's not as nice, but it's just what you have to do. Sometimes you have to. You're better having it in a site that is well connected, one of those two, than a third site that's not at all and doesn't meet those requirements. Or perhaps see if Azure is a good place for you to leave that server. A couple of turbocharging tips. You'll see a few of these throughout. I couldn't think of a better way to put it. If you don't follow preferred architecture to the letter, just follow the best practices that it's trying to imply. You need to stay supportable, but ideally you want to be in that area of best practice. And if you can't do that, then stop what you're doing and go, should we go to Office 365? Because it's all there ready and waiting for you. I'm always a big fan of on-premises, but for the majority of customers, and I go through these projects where the company I work for, we sold a project for them, I'd rather stop them and say, I really think you should actually go to Exchange Online. Now we're looking at the planning. I can't see the good reasons. Even down the road, it's like, let's review whether actually we can go to Office 365 instead, because you know that they'll be left in a much better position if they're in the cloud. That's not the same for everybody, true, but if you can't follow these tips, if you can't follow preferred architecture as closely as possible, then seriously consider Office 365. So namespace planning, load balancing. So there's a few namespace models for Exchange. So what's a namespace? It is the name, like mail.contoso.com, that clients use to connect to Exchange server. So that's usually, in 2016, it is the HTTPS name they connect. And the unbound namespace allows clients to connect to more than one data center with the same name. Now, Exchange receives that traffic. Say we hit data center 1, but our mailbox is active in data center 2. The client will talk to data center 1 for that request, and the client access front-end component on that mailbox server will proxy that request back to wherever the mailbox is active. We don't need to worry about that. It does mean that there will be proxying between data centers. That's part of what you're planning for, though. The bound namespace is where a client connects to a specific data center, mail1.contoso.com, mail2.contoso.com, based on where it's active. So most of that traffic routing doesn't go cross data center. Some access, mailboxes and so on, or calendar access, may do in certain scenarios, but generally what you'll expect is that traffic will stay between those data centers. And that can be necessary if you feel that there's going to be latency issues or other things in your environment that you can't control. So, load balancing options and recommendations. So, always recommend using a layer 7 load balancer. You can use layer 4, But that usually means that you have to have per service names like OWA, EAS, OAB, and so on. And then each of those has to have a load balancer instance with its own IP address, monitoring each service. Or you have one and you just monitor, I don't know, MAPI, HTTP, or OWA. You have to pick one. If it breaks on that server, or it doesn't break on that server and something else does, then you might have a service issue. So use layer 7 load balancing. And with layer 7 load balancing and SSL bridging, what happens is it has an SSL certificate on the load balancer. It takes that request, it unencrypts it, it sees the path that the user is attempting to access, and then it re-encrypts it and sends it back. Don't use SSL offloading unless there's a good reason to do so, which I have never seen. And you don't use any affinity, right? You don't need any sort of sticky sessions for client traffic to the servers. Use an unbound namespace, cross that across data centers. You're better investing in load balancers that can deal with that if you need to keep users stickier to a certain data center because they're closer to it. Perfect example of that might be VDI environments, where you've got 2 data centers and you've got users on VDI in each of those data centers. Then that's a great reason to try and keep people sticky to the data center they're in, but use the load balancer capabilities rather than a bound namespace to keep people stuck to the closest servers for them. And use round-robin load distribution across those servers in the data center as your first choice, where it means that it's just going to pick the next server as it goes along to make sure that it's divided as equally as possible across those machines. So, things that have caught me out. And the first thing that caught me out on a one Exchange 2016 upgrade was the additional latency from moving from 2010. So is there anybody here, show of hands, anybody using 2010 with online mode clients? A small few. I thought there'd be more, but maybe it's just the type of customers I'm working with at the moment, VDI being in one case. And there is additional latency because of all the extra components in Exchange versus connecting direct over RPC to 2010. And I found that was like 3 milliseconds for a same data center, access a mailbox, read an item. But it went up by maybe about 10 milliseconds with Exchange 2016, going through MAPI HTTP, Outlook Anywhere, slightly lower, but we wanted to go MAPI HTTP. Then you add in the data center latency as well. Then that could add another 10 milliseconds on top of that. And then you end up in a scenario where if a user's in online mode, clicking between items, from it being click, 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 and it shows, it's click, 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 and it shows. Or worse, click, click, and it doesn't follow the cursor along. And those are the sort of things that you get reported back and you go, okay, let's try and understand. So understand how the load balancing in place is going to affect the client latency. You can't do much about Exchange. Exchange is fine, right? You know, it's going to do that anyway. You're going to be able to minimize that. The user experience will still be good. 2019, one of the great things about that with that caching is it's going to have extra things to help remove some of that latency too for online mode clients. So that sort of 20 milliseconds latency could add significant delays, all right? So key principle for load balancing, planning client access to Exchange, following similar principles to if you are doing an Exchange Online project. You want to try and reduce the number of hops, reduce the latency between the client accessing or hitting the load balancer and actually getting to their mailbox. So any of those hops across your WAN to the endpoints for Exchange, and then internally within the infrastructure. So do all you can to try and make sure that the round trip time, the ping time, the number of hops on the network is as low as possible. So, virtualizing Exchange, what you should know. I'd love to say don't do it, but I am VMware certified up until 4.5. And when I started blogging, I did start blogging about VMware as well. And I used to be a Unix admin alongside Exchange. So, you know, NFS is something I'm super comfortable with. And that means some of these I've got opinions on that I won't share here, but I get what we know is that there's been problems that drive these decisions. So it's easy to say, well, I've seen Oracle databases run off NFS for years without an issue. Exchange isn't the same thing. So it's not designed to be virtualized. It puts you squarely you are here, right outside that ring. And it's not outside the ring, but it's just on the edge. It's not designed this way. They're not virtualizing Exchange in the cloud, deploying it on Azure, right? They're doing it on physical hardware. This is the thing it's meant for. Did anyone hear about the memory requirements for Exchange 2019? Yeah? Yeah, a few of you? Put your hand up if you're happy with that. No? Yay! If you buy, a few people. If you buy a server now, to be fair, physical server, that's what you're going to get. And you can buy a virtual host with half a terabyte of RAM and stuff like that. It's not, back 6 years ago when I was buying that kind of kit, I was buying 256 gig of RAM. So 192 isn't terrible, but it is a lot. So you can see from that alone, they're not designing it to go into your normal standard virtual environment. Your closet in a small business that it's got a couple of ESX servers in with 64 gig of RAM each that could comfortably run a couple of 8 gig mailbox servers and 4 gig CAS servers, CAS head transfer. Don't know what that was. So it'll get worse from here on in. So it's not designed for those kind of scenarios. It's designed to go on physical hardware, buy the kit. You need to follow these requirements, though, for virtualization. So often you'll see a vendor that either sells a virtualization platform, or maybe they sell you a SAN or NAS, and they will say, this is our blueprint for Exchange. Don't take on their advice. It's probably good advice. It's not always the best advice. I won't be the first person to have heard a VMware person or a virtualization person say, just use VMware HA to deal with high availability for Exchange. It's fine. Don't do that if you can. Design it as if you were going to do a physical environment and then deploy to a virtual one. If they've got great advice, take it on board, but take it in as your good advice that's helping you reduce risk, especially if that means they'll take on some of the support responsibility. And as I said earlier, some people say, well, I'm going to do PA on a virtual environment. Well, you're not. But the key concepts that you can take on board, because you can't do a physical server, obviously, well, ultimately it is, I suppose. Namespace design, the unbound namespace across multiple data centers, at least 4 copies of the database. Again, this is where it gets expensive in a virtual environment, because it no doubt will be on RAID storage. So you've probably got at least 8 copies now of your data. So it's going to be more expensive, but take on board as much of that as you can to make sure that you're designing a highly available, supportable environment. So things that are supported. I should probably say, when Greg was saying, it's really good, Greg Taylor, he said, what I want you to do is try and bring in some of the things from the previous sessions that we've done in the past. So I'm trying to do the Jeff Milliff session again in 5 minutes to give you that advice and then some of mine on top. So this is all the Microsoft advice, not the Steve advice. What is supported? So Hyper-V, obviously, any Hyper-V, and any other hypervisor, like VMware, so on, that's on the server virtualization validation program. All roles, Mailbox and Edge, they're all supported. Hybrid role also are all supported in a virtual environment. VMware HA, where similar solutions where physical host that's running on dies and it boots up on another server, that's supported as long as it's a cold boot. As long as Exchange sees this as someone pulling the plug on a server and putting it back in. Block-based storage, as in storage that is not file-based, like NAS storage is supported, so virtual disks, VMDKs that sit back to Fibre Channel SAN, SCSI, iSCSI pass-through, and fixed or thick provision disks are supported. Dynamic disks are as well, or thinly provisioned disks. But the key thing is, if you're thin provisioning all your storage and maybe buying it as you need it, the Exchange supportability stance is you must have the right amount of storage there, even if you're thin provisioning, in case something happens. And one thing I'd say is the exclusion that I would have in my mind was, do I do that for a recovery volume? I would, if you're following it to the letter, probably you'll need to do that. And on SMB3 based NAS storage, fixed virtual hard disk files. Things like vMotions is supported, absolutely fine, but one thing to watch for is cluster timeout issues, because there's a little moment of time when a virtual machine migrates from one to another, or one host to another, that it isn't running, and sometimes the cluster default settings can invoke a database failover. So you might find that if you've got automated distribution of virtual machines across your virtual environment, it's a good thing, then you might find that suddenly all your databases are sitting in a non-optimum state on a smaller number of servers. So make sure that the cluster doesn't get affected by those kind of things. And obviously, jet stress testing is supported. It wasn't always supported. Jet stress against the storage you're actually going to be using. That can be difficult in a virtual environment, especially over time, but even at the beginning, because it might be auto-tiering storage. So watch what happens there, because that you live or die by the jet stress tests. Things that aren't supported, though. Dynamic memory, so that's where we say to Exchange you've got 192 gig of RAM, and the host says, or VMware might say, you're not using that. So it swaps it off to disks. It takes it out of real memory, puts it onto disks, and then Exchange says, well, I've got that right there, I'll quickly give that to you. And then it has to go and get it from disks. It has massive performance impact. Or dynamic memory, where the memory on Hyper-V grows. It works great in the lab, but not so much in a production environment. Snapshots. I'm not going to ask whether anyone's ever done this or does this. If you say yes, I'll die. But I've heard someone say, before we do the CU or service pack for Exchange, we're going to snapshot it. Yeah. But it relies on things innate. It's not, you can't roll back from a snapshot with Exchange. So unless you roll back the entire environment, including AD, because Exchange works well with Active Directory, keeps a lot of its config there. So snapshotting Exchange isn't supported. Differencing disks, where you might have a master OS disk, and then when you deploy a template from that, you're using differencing disks or link clones to actually deploy the real data on. Not supported. No server applications. You can't run an AD domain controller with Hyper-V and a stick Exchange as a virtual machine on it. NFS is not supported. 4 years ago, that's always a big thing. When will it be supported? Will it be supported? And a bit of my old Unix admin brain is like, well, if iSCSI supported it, and anyone can make an iSCSI implementation, but NFS isn't, what's going on there? But it isn't. Way past that, it's never going to be. So if you're running a SAN that presents NFS storage to, say, VMware, and then on top of that, it then has the block-based disks as files, not supported. Lots of people have done that, though, especially with enterprise SAN vendors. Guest OS disks need to be on different spindles to Exchange databases. This isn't one I always knew, but different physical disks to the databases themselves. And CPU oversubscription, that's where you might have, say, 4 CPUs or four cores in a server, and you've got 8 virtual machines each with a core each. That's oversubscription by 2 to 1. That's okay, but any more isn't. 1 to 1 is recommended. A few tips, though, to turbocharge. Scale out rather than up, right? If you've got a great big virtual infrastructure, don't just buy, let's have 2 ESX hosts. Or you can see where of course I'm a Hyper-V person, not. So say you've got Hyper-V hosts, 2 of those are aligned to Exchange. Don't do that. Spread the load across the environment if you can. Lots of smaller machines. With 2016, maybe not so much 2019. Spread across the virtual infrastructure. They're better for availability than a small number. 2 machines running Exchange may provide you what you need, give it all the storage it needs, it may perform well, but it doesn't give you that good availability. So smaller VMs spread across that environment are going to give you a better experience in terms of failure and distribution and performance. And some of the cool stuff inside virtualization technology spreads that load accordingly. So if some hosts are busy, they'll move virtual machines to another host. What you don't want to happen is all of your servers, all of your Exchange servers landing on the same physical host. So anti-affinity rules that you can set in the environment that make sure that they never end up on the same hosts are essential for that. And think about other things that might impact it as well, like Active Directory domain controllers, your file share witness, and so on. Make sure that you're not putting all your eggs in one basket. Make sure you reserve memory for CPU and Exchange. So that's how to make sure that you don't overcommit memory. 100% reservations, for example, to make sure that all the RAM is always available when Exchange needs it. It's a common mistake to make, and it impacts performance. And start with all the Exchange high availability. Do it that way first, as if you were designing for physical. There's nothing then wrong with adding in the high availability functionality within your virtualization environment. It's great. It's doing more things for you. So if a physical server dies, then the environment won't be down. But use them both together. Use the Exchange functionality first, then go for the hypervisor stuff to supplement that. And try and keep it as simple as possible. If you're doing it virtual, that's very difficult to achieve. In my career, I've spent days looking at a tool called ESX Top, trying to understand what's happening with I/O via iSCSI, going through switches that turn out not to be up to the job, trying to troubleshoot where the performance issues were. That's not the place you want to be in. And if you're in an enterprise environment, or you're not a consultant with doing this, and you happen to have both of those skills, mine are rusty, then you don't want to have to rely on somebody else to get to the bottom of that. Because I hate to be the person that goes, it's the network. It's always the network. In fact, that latency thing I mentioned earlier, that was the network. That was, they thought it was Exchange. I'm like, well, I'm not going to blame the network. Let's get to the bottom of it. It was the network. It was dropping packets. So keep it as simple as possible if you can, right? You're adding all of this complexity. You're adding all of these layers that are sitting on top. What can you do to just try and keep this simple? So one quick slide here is your toolkit for deploying Exchange. So these are the things you should definitely use. So you want to understand, before you deploy and size your next version of Exchange, how much data is going to be written to disk and read from disk, and how often that will be. So generating the message profile will tell you what the averages are for how many messages are being received and the size of those. They're key for not only understanding the client bandwidth, but understanding how much I/O, how much reads and writes are going to go to the back-end storage with Exchange. Obviously, the server role requirements calculator, I should say. This is your tool for deploying Exchange, and it is the thing that helps you out. The most useful part of that that I've used in Exchange 2016 deployments has been the fact that it can generate the scripts to set up the database availability groups for you. Again, if you're doing preferred architecture and you're trying to use these database layouts that it generates, using the scripts that it gives you to set up the environment, to set up your DAG, is such a time saver. It's giving you the tools you need to deploy it, and not just giving you the bits that go in the design, it's giving you the scripts to actually get it right and set it up and format your disks and set up the databases and set all the right settings on them. So use the scripts that come with it. When you're filling out the role requirements calculator, then you'll need to understand what the CPU is and get the spec in value. And you'll see that there's a way of doing that and calculating that yourself. This is an oldie but a goodie. And the processor query tool, you can pop in the CPU, it will query that from the internet, and it will tell you what that is. It will tell you what you can put in virtual, how many cores you're going to allocate to it if you're doing it in a virtual environment, what the ratios are. It'll give you the right value to go in. You can do it by hand just to double check if you want, but it gets that information for you. It's pretty good in most cases. Where you've got more complex deployments, something that came out from Microsoft this year was a database sizing tool for the transport database. And that's useful if you've got maybe multiple DAGs and you have multiple calculators to use for these, but you're trying to understand what the impact is going to be cross DAGs. You can calculate that by hand. It's hard to do right if you're bad at maths like me. But this will do that for you. You'll be able to understand the size of the transport database, irrespective of the exchange DAGs and things like that. So you can consider all the mail flow that's going in. Or perhaps you're going to be journaling off to somewhere in the cloud or on premises and sending out additional emails. So you can size it without having to size the whole environment to cope with it. So it's useful for validating stuff. Follow preferred architecture, it's not so important because likely you'll have far bigger disks than you need. But if you are doing any sort of virtual environment, this is one that could catch you out. The jet stress tool and the field guide, it says 2013. It's still just as valid today. So use Neil Johnston's field guide to understand how to properly test the environment. The best thing you can do is use jet stress to understand whether you've got any deficiencies in the storage infrastructure. That could, one thing that you might find is the people that have set up the service for you haven't configured the battery back cache correctly, for example. Or there's a firmware issue in some of the disks in the servers you bought. You're trying to make sure that it's not that the environment works the way that it's been designed or meets that, or meets those kind of requirements. It's trying to make sure that what we've got is the physical hardware that we bought is actually up to the job. And the Exchange Environment Report, that's a good tool for grabbing information about your environment and getting a nice HTML report. So I've got a couple of minutes left, and I wanted to give you just 2 tips on Exchange Hybrid, because I know Michael van Horenbeek has done a similar session going into detail on this earlier in the week. So best thing about hybrid, if you're going on premises though, is being able to use things like conditional access in the cloud. And that's the bottom one there, modern auth. But it might be accelerating your migration, right? So if you're moving to Exchange 2016 because you want hybrid, then you probably shouldn't add 2013 or 2016 servers. 2010 has got in everything you need. If you're running 2013 and the plan is to migrate, then don't add 2016 servers either. So the one thing you need to bear in mind is that adding 2016 servers isn't going to improve your migration performance. In fact, it might make it worse. And this is why. You may have seen a version of this before in the hybrid for the long-term slides. So should I install a 2016 server? Well, usually the traffic's all hitting 2010 there. Migration hitting there. If we add 2016 in, then our client access moves to there, potentially a bottleneck on performance. But we're still reading off the same physical disks at the back end on 2010. It's not going to improve performance. But you can improve the migration experience by starting with a healthy Exchange environment. Optimize the route from Exchange Online to on-premises to make sure it gets to the Exchange servers without any interference. Less is more. And use multiple migration endpoints to increase throughput. Instead of just one, through your load balancer, have multiple ones. The service will be able to use more migration endpoints to increase throughput rather than the limitations of one, and it will give you better performance from your environment too. And if you've got multiple regions, then use multiple endpoints. So it might be that you've got a European division and a North America division, have endpoints in each region rather than going through one and then going across your WAN. You want to reduce the round trip time between the servers in Exchange Online and the servers on premises. Because when you're pulling lots of items from mailboxes, it's like doing a file copy with millions of items. There's a back and forward that you need to be aware of. So in summary, use PA where you can. It's your starting point for success. Make sure that you follow all the Microsoft documentation for doing it in a virtual environment. Scale out rather than up. Always use the role requirements calculator to plan an exchange. And if you're running Exchange 2010 or higher, then you probably have everything you need to perform a migration to Exchange Online. One last thing that Greg has asked me to mention is, and get ready with your smartphones or the internet if you want a copy of Tony Redmond's book, Office 365 for IT Pros. We've got 50 copies to give away today. First 50 of you to get that code in, get a copy. I'm going to be around at the end of here for questions. Feel free to come have a chat. I'd love to meet all of you. But other than that, thank you very much for attending my session today.